I'm going to explain to you what happens when a liquid is a solid. Right now, the particles in the solid are just moving around in a fixed position. And when it starts melting, it goes up, the temperature raises up, and so does the kinetic energy, which causes the temperature. And once it hits a certain point, then it stays the constant temperature while it's melting. It goes to liquid. It goes from a liquid to a solid. It starts freezing and goes backwards. And a crystalline solid is a solid that puts back when you hit it, or so. Amorphous solid is a solid that does not push back. A good example of that is glass.
Now you see, liquids. They will conform to the container, but they will not. But they have a fixed volume, which means they will not expand over the container. Liquids, unlike solids, their particles move past each other, kind of like gliding across one end of the football field to another. They have a higher kinetic energy than a solid, but lower kinetic energy than a gas. And when the temperature reaches a certain point, the liquid starts to go through vaporization, which can go in either boiling or evaporation. Once all of the substance reaches a certain temperature, it will then go to a gas. The same thing happens, though it's opposite, and condensation occurs, and it goes back to a liquid. Okay, now a solid can go, a gas can go from a solid to a gas. A gas can go to a solid instantaneously through sublimation. Sublimation is, it's the opposite. It's through deposition. In deposition, an example of this would be more of a dry ice, where when you have dry ice, it'll sublime to come back to gas as it slowly breaks down. After gas, it's plasma, and it gets there through ionization, which means the particles are extremely charged, and it's in fact so charged that an example of this would be lightning. And the way it gets back to gas would be deionization. Now, plasma, the particles are extremely hypercharged, and everybody's seen what happens to lightning.